Okay, Mr. Trutna here. We're going to go over the worksheet properties of parabolas. This is the first worksheet from Unit 10 that we just started, okay? And we're going to be focusing on how to identify the vertex, how to make a quick sketch of a graph of an equation, and then on the back side we're going to be focusing on how to get the axis of symmetry's equation, how to identify the axis of symmetry, okay? Okay, so numbers 1 through 4, we're identifying the vertex of each of these equations. So remember, when you identify the vertex is a point. So since the vertex is going to be a point, that means you need to identify the vertex as an ordered pair. So you need an x value and you need a y value. The way that you get the x value is you use the formula x is equal to negative b divided by 2 times a, or negative b divided by 2a. Okay, so you look at the equation. The number in front of the x squared, which there is no number there, so that means that there's a 1 right there. That's your a value. Okay, so in this equation, I know that my a value is going to be 1. Your b value is going to be the number in front of the x, so your b value is positive 16. Okay, and then there actually is a c value, and your c value in this problem is going to be 64. It's the number that does not have a variable next to it, although we don't need the c value for this particular equation. Okay, so using the equation, I take b, I'm going to take the opposite of it, or the negative of it. Since b is 16, that's going to give me negative 16. Then I'm going to divide that by 2 times the a value, and the a value is 1. Alright, so negative 16 divided by 2 gives me negative 8. So my x value is negative 8, so that's my vertex's value. Then, to find the y value, what I do is I take my x value, negative 8, and I'm going to substitute it into my equation in the place of x. So I'm going to get y is equal to negative 8 to the second power plus 16 times negative 8 plus 64. Okay, now if you have a calculator like mine that has a scrolling screen on it, what you can do is you could just type in this equation just like it looks, because it'll scroll through my screen. So I go parentheses negative 8 to the second power plus 16 parentheses, or times negative 8, I close the parentheses, plus 64, I press equals, I get 0. Okay, so my y value is going to be 0. So there we go. I just identified my vertex. My vertex is the point negative 8, 0. Your vertex always has to be a point, so it always has to be expressed as an ordered pair. Okay, number 2, we're going to do the same thing. So I'm going to identify the vertex. So I'm going to identify my a value. So my a value is going to be 2, the number or the coefficient in front of the x squared. My b value is going to be negative 4. Your b value is always the number or the coefficient in front of the x. And then my c value, I don't need it, but for this equation, it's going to be my last number there. It's going to be negative 2. Your c value is always the number that does not have any variable next to it. Okay, so my vertex, to identify my vertex, once again, the vertex is a point, so I'm going to have to identify it as an ordered pair. To find the x value of the vertex, you use the formula negative b divided by 2 times a. Okay, so I would get negative, and then my b is negative 4. So this would become negative 4, which really is going to make that a positive 4 for my numerator. Then my denominator, I'm going to divide that by 2 times a. A is 2. 2 times 2 is 4. 4 times 4, 4 divided by 4 is 1. So my x value for my vertex is 1. To find my y value, I'm going to take my x value 1, and I'm going to substitute it into the place of x in my quadratic equation here. So I'm going to get y equals 2 times 1 to the second power minus 4 times 1 minus 2. Okay, and we work that out. And once again, if you have a scrolling screen calculator, and I highly suggest you get in one, you could just type in the equation as you see it. 2 parentheses 1 to the second power minus 4 put a parentheses, put a 1 in it, close the parentheses, minus 2, you press equals, we get -4. So my y value is -4, so I identify my vertex as the point 1, -4. Okay, moving on to number 3, I'm going to do the same thing. So my a value is -1. We have this negative sign here. There's no number, so that makes a -1. My b value is going to be 18, and my c value is going to be -75. Okay, to identify my vertex is going to be a point, so I need to identify my ordered pair. Okay. To find the x value of my ordered pair, I use the formula x is equal to -b divided by 2 times a. b is 18, so I'm going to get a -18 divided by 2 times a is -1. Okay, that would become -18 divided by -2, so I get +9. So my x value for my vertex is going to be +9. Now to find my y value, I take +9 and I substitute it into my equation. So I'm going to get a negative and then a 9 to the second power. Notice every time I substitute a number in the place of a variable, I always put it in parentheses. Plus 18 times 9 minus 75. And then I type this into my calculator. So I do the negative sign. Then I go parentheses 9 to the second, close the parentheses to the second power, plus 18, parentheses 9, close the parentheses, so I'm timesing by 9, multiplying by 9, minus 75, I get 6 for an answer. So my y value is 6. So that means I've identified my vertex as the point 9, 6. Okay, number 4, the last one where we're identifying the vertex, I'm going to do the same thing here. So I'm going to take my quadratic equation and I'm going to denote that the a value is -3, the b value is +12, and my c value is -10. Okay, in order to find the vertex, remember the vertex is a point, so to identify the vertex we need an ordered pair. To find the x value, I use the formula -b divided by 2 times a. Okay, b is 12, so I'm going to get -12 divided by 2 times, and my a value is -3. Evaluating this, I would get -12 divided by -6, so I would get my x value as +2. Okay, to find my y value, what I do, I'm going to take +2 and I'm going to substitute it into my equation in the place of all the x's. So I'm going to get -3. X turns into +2 to the second power, plus 12, substitute 2 in the place of x, minus 10. And then what I do is I'm going to just type this into my calculator. So -3, parentheses 2, close the parentheses to the second power, plus 12, parentheses 2, close the parentheses, minus 10, I get 2. So my vertex is, when x is 2, y is 2, so I identify my vertex as the point 2, 2. Okay? All right, number 5. Now what we're going to do in this problem is we're going to graph the equation. So we're going to graph the equation y is equal to x squared minus 2x minus 3. Okay, so whenever we graph an equation, now once again, look at the equation. We know that my a value is 1. We know that my b value is -2. We know that my c value is -3. So the first thing that I'm going to do is I'm going to identify where the vertex is. Okay, so I'm going to do the same thing that I did in numbers 1, 2, 3, and 4. So to find the x value of the vertex, I'm going to take -b. I'm going to divide it by 2a. So b is already -2. So I'm going to get a negative and then a -2. So that's going to give me a +2. And then I'm going to divide that by 2 times my a value, which is 1. So I'm going to get 2 divided by 2, that's 1. So my vertex is 1. Okay, so we can see right here, this point right here on my table is going to be my vertex. Okay, now I'm going to plug that number 1 into this equation to find my y value for my vertex. Okay, so my y value, when I plug in 1, I'm going to get 1 to the second power minus 2 times 1 minus 3. Okay, I work this out, and I could do this in my head. 1 to the second power is 1, minus 2 times 1. 1 minus 2 is negative 1. Negative 1 minus 3 gives me a y value of negative 4. Okay, so I'm going to plot that point. 1, negative 4. I'm going to put a point. That's where my vertex is. Okay, then I'm going to draw my axis of symmetry. So remember, your axis of symmetry is always going to be a vertical line that goes right through your vertex. Okay, that's going to be the line that cuts your parabola into 2 equal parts. It's going to make it symmetrical. So what that means is that all I have to do to fill out this table is, I need to plug 2 into this equation. So watch what happens when I plug 2 into this equation. I'm going to get 2 squared minus 2 times 2. So that's going to be 4 minus 4. So I'm at 0 now. Minus 3. So this is equal to negative 3. So I plot the point to negative 3. So I go over 2. I go down 3, and I put a point. Now, because it's symmetrical on both sides, that means the point on the other side of the line of symmetry is going to be in the same spot. So that means when I put in 0, excuse me, I'm going to get negative 3. Okay? And so I have these 3 points. Now, to make a parabola, to graph a parabola, all I really need is these 3 points. So what I do now is I just connect the 3 points with a nice smooth U. Remember, parabolas are always U-shaped graphs. Just extend it up a little bit past the points, put arrows to show that this parabola goes continuously up. So that would be a sketch of the graph of number 5. Okay, moving on to number 6, I'm going to do the same thing. So the first thing that I'm going to do is I'm going to identify the fact that my A value is negative 1, my B value is negative 6, and my C value is negative 10. All right. Now I'm going to figure out which one of these numbers here represent my vertex. So in order to identify my vertex, I'm going to identify the x value, which is negative b divided by 2a. Okay, my b value is negative 6, so I'm going to get a negative and then a negative 6. So that's going to give me a positive 6. I'm going to divide that by 2 times my a value, which is negative 1. 2 times negative 1 is negative 2. 6 divided by negative 2 is negative 3. So you can see this point right here is my vertex. Okay, I need to figure out my y value for my vertex. So I take my x value and I'm going to substitute or plug in negative 3 in the place of x. So when I do that, I'm going to get a negative, then a negative 3 to the second power, minus 6 times negative 3 minus, I'm going to run out of room here, out of paper, 10. Okay? And then I type this into my calculator. All right, so, and I have a scrolling screen. This makes it a lot easier. Invest in a scrolling screen calculator. It helps. Negative, parentheses, negative 3, close the parentheses, to the second power, minus 6, parentheses, negative 3, close the parentheses, minus 10. That gives me a y value of negative 1. So my vertex is x is negative 3, y is negative 1. Okay? Now I draw my axis of symmetry right through my vertex. All right? So my axis of symmetry always aligns with my vertex, goes right through it. Okay, and then my parabola is going to go, and actually this parabola is going to be a downward continuous parabola because my a value is negative, so that's going to be my maximum point. All right, so now what I need to do is I need to pick one of these points here, and I need to substitute one of those points into my equation. Okay, I'm going to go ahead and substitute in negative 1. All right, so when I substitute negative 1, I'm going to get negative 1 to the second power minus 6 times negative 1 minus 10. Okay, hopefully you can see that on the screen. It's really, really small. I'll zoom it in so you can see it just a little bit better there. Okay? Okay, then I evaluate this. So I'm going to take that and I'm going to type this into my calculator just as I see it. because I have a scrolling screen calculator. So I'm going to go negative, parentheses, -1, close the parentheses, to the second power, minus 6, parentheses, -1, close the parentheses, minus 10, that equals -5. So when x is -1, y is -5, I'm going to plot that point on my graph. -1, 1, 2, 3, 4, 5, -5. Then, that means this point, which is the same distance away from the vertex, notice they're the same distance away from the vertex, is going to be the same value. So when x is -5, y is -5, and it has to be that way because parabolas are symmetrical. So that means I'm going to plot that point right there. Okay? And now to graph it, I just connect the points with a nice smooth parabola, extend the parabola past those last points there, and we've got our picture of what our parabola looks like. Okay? So that's kind of how we go about graphing right there. All right, going to the other side. So now on number 9, we're going to go ahead and do number 9, and we do number 9 the same way. Okay, so the first thing that I'm going to do is I notice that my A value is 1, my B value is 2, my C value is -1. Okay, I'm going to find my vertex, so I'm going to try to figure out where is my vertex. One of these points is probably going to be my vertex. So I use the formula x is equal to -b divided by 2 times A. B is 2, so I get -2 divided by 2 times A. A is 1. That becomes -2 divided by 2, so I get -1. So you can see right here, that point is going to be my vertex. I'm going to substitute -1 into my equation to see what this equals. So when I do that, I get -1 to the second power plus 2 times -1 minus 1. And I work this out. -1 to the second power is 1. 2 times -1 is -1, so I get 1 plus -2. So that would be -1. -1 minus 1 is -2. So when x is -1, y is -2. I put a point. There's my vertex. My A value is positive, so my parabola is going to go continuously up. This is going to be my minimum, my lowest point. Okay, then I'm going to pick one point above and one point below to get points on either side of my axis of symmetry. Here is my axis of symmetry. Remember, your axis of symmetry always goes right through your vertex. Okay, I'm going to put 0. 0 is a nice easy point to pick. When I do that, I get 0 to the second power plus 2 times 0 minus 1. Work that out, it's equal to -1. I plot the point 0, -1 there, and that means that when -2 is also going to be at -1. I don't have to do the math because it's symmetrical on both sides, so -2, -1. Okay, I connect the points with a nice smooth U, extend the line or the parabola up to show that it goes continuously up. There's my graph of number 9. All right, moving down to number 11, we're going to identify the vertex and the axis of symmetry. All right, well, so my A value is 3, my B value is -54, and my C value, once again, I'm not going to need my C value for this exercise, is 241. You will need it later on in another exercise. Okay, so to find the vertex, so I need to identify the vertex. The vertex is always a point. A point is always expressed as an ordered pair of numbers, so I need an x and a y value. To find the x value, I use the formula -b divided by 2a. Okay, b is already -54, so I'm going to get -54, so that's going to be 54. Then I'm going to divide that by 2 times my a value, which is 3. That's 6. 54 divided by 6 gives me a vertex's x value of 9. Okay, now to find the y value of the vertex, I substitute 9 into the equation. So I get 3 times 9 squared minus 54 times 9 plus 241. I type this into my scrolling screen calculator. Hopefully you're getting the point. Get a scrolling screen calculator It makes your life a little bit easier on these problems. Okay, and I type it in. So I go 3 parentheses 9 to the second power minus 54 times 9 plus 241. You can see that equals negative 2. So my vertex, I've identified my vertex as 9, negative 2. Okay, next I'm going to now find, I not only need to find my vertex, I need to find my axis of symmetry. Okay, so what is my axis of symmetry? So if you recall, your axis of symmetry is always a vertical line. So to identify it, you always write x equals. The only variable you write is x for your axis of symmetry. That's always going to give you a vertical line. And what does x equal? Well, you look at your vertex, 9. So my axis of symmetry is identified as x equals 9. All right, number 12, same idea. I'm going to identify the vertex, and I'm going to identify the axis of symmetry. So my a value is 1, my b value is negative 18, and then my c value, which I don't need, but it's a good idea to identify it, as 86. Okay, so now I'm going to identify my vertex. So so my vertex is a point. A point is always identified by an ordered pair. To find the x value of the point, once again, I use the formula negative b divided by 2a. Okay, b is negative 18, so I'm going to get a negative and then a negative 18. That's going to turn into positive 18. I'm going to divide that by 2 times my a value, which is 1. 18 divided by 2 gives me my vertex's x value of 9. Okay, to find the y value, I substitute that 9 into x into my quadratic equation. So I get 9 to the second power minus 18 times 9 plus 86. Okay, type this into your calculator. So you go parentheses 9 to the second power minus 18 parentheses 9 plus 86. We get 5. So my y value is 5. So that means I've identified my vertex as the point 95. If you know where your vertex is, you can also quickly identify the axis of symmetry. Okay, so how do you do that? Well, remember, the axis of symmetry is going to be a vertical line. A vertical line's equation is always x equals, and then you put a number here. The number you put is your x value of your vertex. So my axis of symmetry is identified by the equation x equals 9, which would be a vertical line going right through 9 on an axis. All right, so the last problem that was assigned to you was number 18. Number 18, we're identifying the vertex and the axis of symmetry. Okay, so my a value is 1. That's the number in front of the x squared. My b value is positive 4. And then my c value is going to be positive 5. To identify the vertex, I need to represent it as an ordered pair. So I need an x value and a y value. To find the x value, I use the formula negative b divided by 2a. b is 4, so I get negative 4. I'm going to divide that by 2 times a, which is 1. So that's negative 4 divided by 2. So I get my x value of negative 2. That's my vertex, okay? For the x value. I find the y value now for my vertex. I substitute negative 2 into my quadratic equation for x. So I get negative 2 to the second power plus 4 times negative 2 plus 5. Okay? Use your calculator if you got one. This one you could probably do in your head. Negative 2 squared is 4, plus 2 times negative 4 is negative 8, plus 5. So 4 plus negative 8 is negative 4. Negative 4 plus 5 gives me 1. So my y value is 1. So my vertex has been identified as the coordinates negative 2, negative 1. And now I can identify my axis of symmetry. So keep in mind, whenever you identify the axis of symmetry, it's always an equation. It's always x equals. And the reason for that is because x equals will always give you a vertical line, and then the number that the axis of symmetry's x is equal to is your vertex's x value. So there's my axis of symmetry. Okay, come in and get more help if you need it. Otherwise than that, hopefully the video helped.